So 2.3, we're talking about information. I titled it essential information from a graph. Okay. So once we get a graph, or once we find out what the graph is, you guys will have ample information to either graph it, or a graph will be provided for you. Okay. And with that graph, we can get some information. We're going to look at 4 specific things. Okay. So information, number 1. Okay, the first thing is the domain. We should know what domain is already, right? What is domain? All possible x values. Okay. The second thing that goes with domain is range. Your range is all possible y values. And how we're going to represent that is interval notation. Okay. All right. Where is the graph increasing or decreasing? Okay. Increasing is the interval of your x values where graph is going up from left to right. Okay, so when you look at a graph, and we're gonna be doing examples from left to right. When you look at a graph and it's going from left to right, where is it going up? Yeah, you're gonna get those 2 intervals. Yeah, on the x, your x value, you're gonna get those x values and put it in a interval notation. Okay. So number 4 is decreasing. Okay. Interval, it's basically the same thing of x values as increasing, where graph is going down from left to right. Okay. Number 5 local max. Okay. The word local, what does that mean? And number 6 is local min. What does the word local mean? Not in Spanish. Huh? Near? Like, yeah, it's near, right? It's a community, right? Yeah, local community means La Crescenta, right? For example. So your local max is the top of a hill or a mountain. And I'll go into that a little more detail once we get into an example, and that will make sense. Okay. And how we find the local max, or how we represent that, is the local max is equal to y value at the x value equals blank. Okay, it's going to be like that. Y value at x equals blank. So then the local min would be the bottom of a valley. Okay, and again, it will be y value at x equals blank, or the coordinate. Okay. And with 5 and 6, we can have multiple. Okay. We could have multiple. We don't need multiple, but we could have it. Number 7, the last one, is your x and y intercepts. Okay, and I don't have to go over that because that's just what it is. Right? Questions on that? No, so let's go over some examples. Okay. I printed the book out so it's easy to see. Let's try number 7. Okay. It says the values of a function, the graph of a function h is given. So this is my graph, right? A, find h of -2, h of 0, h of 2, h of 3. You can all do that, right? That's 2.1, 2.2, right? So quickly, let's review that. I'll give you guys about, I don't know, 2 minutes to get those values. So I'm just going to do one for reference. Okay. To find h of -2, all we're going to do, oh, from the graph, oh, that's what's different, huh? Because we got to do it from the graph, and 2.1 and 2.2 was from an equation. So if we have to find h of -2, and this is my graph here, what does the -2 represent? My x coordinate, right? Because it's h of x, right? So if x is inside my parentheses, and I'm trying to get h of -2, h or -2 is x. So all we do is go to my x value, -2, right here, and then look at where the graph is. And that graph is 1. So h of negative 2 is 1. Okay? Simple, right? H of 0, look at 0. Where's my graph? That's at negative 1. So that's at negative 1. Okay? That makes sense? H of 2. You look at 2 on my x coordinate or x-axis. 2 is right here. Go up to my graph. That's 3. H of 3. Go to my x value at 3. Go up to my graph. That's 4. So that should be your answer. Okay? Questions on that? All right. So to find the domain and the range, remember the domain is all possible x values, right? And the range is all possible y values. From this graph, I don't know why I'm yelling, but from this graph, all possible x values, it starts from this point at negative 3 and it goes to 4, right? So your domain in interval notation would start off at negative 3. Oh, you guys can't see that. Yeah, start off at negative 3 and go to 4, right? Do you include negative 3 and 4? Yes. So you bracket that. Okay? If it was an open circle anywhere, yeah, at the ends, then it would be a parentheses, right? So your range is all possible y values. If you look at your y values, the maximum is 4. The minimum is negative 1. So it will be negative 1 comma 4. And again, they will be bracketized because that's a word. Look it up in a dictionary. Bracketized. We would use brackets because they're included, right? Okay. C, find the values of x for which h of x equals 3. So class, if h of x equals 3, what does the 3 represent? The y value, right? Because in general, h of x would equal y. Okay, the function f of x equals y, right? Same thing, h of x equals y. So 3 is your y value, right? So you look at your y value at 3, and it's here, and it's here, right? So then your x value would be at negative 3, or what is that, 1, 2, 2. Okay? Yeah. You look at 3, my y value at 3, get negative 3, and then get 2. So x would equal negative 3 or 2. Simple. Yeah, all you guys got to do is figure out what you're looking for and just look at the graph. Okay? Part D, find the values of x for which h of x is less than or equal to 3. Again, that 3 represents y values, right? Yeah. So we would look at y values of 3 and look everything down, right? So all of this here h of x is less than 3, correct? So all we got to do is get that interval, okay, from your x values. So we look at the x values. Again, that's -3 and that's 2, right? Because if it equals 3 at -3 and 2, yeah, it's going to be between -3 and 2. So your answer for D would be interval notation, -3, 2. And since it's less than or equal to, do we bracket or do we parentheses? Bracket. Okay? That makes sense? Yeah. Simple, right? Ooh. And I'm gonna leave E for a little bit. Okay? Because that's 2.4. You know what? Let's just do 2.4 right now too. Let's just add that to our list. Where's that list? This list. Number 8. Net change. Okay. The net change, I need lotion. Is I need to cut my nails and have. That's why I don't like to use it, because you get to see my hands. I'm sorry, I lost my train of thought. Net change. So in these graphs, right, most likely it's gonna be a non-linear graph, meaning it's gonna be a curve, like what we did in number 7. There's a curve and a little curve here at number 8. Here's 2 curves at number 9. Here's 2 curves at number 10, right? So it's not gonna work. We graduated from lines, okay? Like graphing lines. We did that in 1, right? We graduated from that, and now we're getting into curves. But net change is just a fancier word for slope. Okay? And we've talked about slope. We know what slope is, right? In a line, it's rise over run. It's essentially the same thing. Yeah? We're gonna get the rise over run of the curve. What? How do you get the rise over run of a curve? Does that make sense? Yeah? So let's take this graph, for example, right? We have this W, but I want the net change from the 0, -1, -2, -2 to 2. Yeah? So how do we get the slope from -2 to 2? What this net change does, right, is it would make a line between those 2 points, and we're essentially getting the slope of this line. Okay? Does that make sense? Mathematically, that's what it means. Okay, if we want the net change between 2 points, we're going to hypothetically draw a line between those 2 points, right? Like what I did here, and get the slope of that line. Okay, so it's nothing new. It's just different terminology and different way of approaching it, right? Okay, questions on that? So your net change or slope is the same thing. It's just going to be y2 minus y1 over x2 minus x1. That's all we're doing. Okay. But it's net change, it's not slope, because we're getting a net change between the curve and not the actual line, right? not an actual line on the graph. So here, going back to this, E, find a net change between x equals -3 and 3. If x equals -3, that point would be -3, comma 3, right? Yeah, -3, 3. And at x equals 3, my y value is 4. So that point is 3, comma 4. And we're going to get the slope of that. Okay? So essentially, if I draw that line from here to here, we're getting the slope of that line. Okay? So I'm going to label this 1, label this 2, get my net change. It will be 4 minus 3 over 3 minus -3. So that would be 1 over 6. Yeah. Okay. And that's the same thing from here. If I go rise, which is 1, up 1, 1, 2, 3, 4, 5, 6. Yeah. Rise over run algebraically, rise over run graphically. That's their net change. Okay. Questions? Let's try one more. Yeah. Let's try number 9. There's two graphs, F and G are given. Yeah, F, if you guys can't see this, is the one that's going up. G is the one that's going down. Okay. Yeah. Okay. So for part A, it says which one is larger, F of 0 or G of 0? Well, if you look at 0, right, which one's larger? What Y value is larger? F or G? F. Because F of 0 is 3, G of 0 is like 1/2. You guys look at the graph? Yeah. Okay. F of 0 is here at 3, G of 0 is here at 1/2. So obviously F of 0 is larger. Which one is larger? F of -3 or G of -3? We look at -3 on my X value. G is up here at 2. F is down here at -1. So obviously G is larger. Yeah. So G of -3. For part C, I know you guys can't see it, but then just follow my words. For which of the values of X is F of X equal to G of X? Okay, part C, right here. Okay. And if we go, where is F and G equal to each other? 2 and -2, where they cross, right? Where the two functions cross and meet at a point, right there, and right there. It says for which values of X, so X is -2, and X is +2, okay? So we did B and C. Part D says which of the values of X, find the values of X for which F of X is less than G of X, less than or equal to. Okay, so we're trying to get this. Yeah. Where is f less than or equal to g of x? Can you guys get that? Matt. -4 to -2, right? F is lower than G. So part D would be, I don't want to write it here. So then part D, I'm going to back up for a little bit, would be the interval of -4, comma -2. Where else? 2 to 4, right? Now, is it bracket or parentheses around both? Bracket, 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 bracket. And remember, in order for us to write it correctly, it will be bracket -4, comma -2, union bracket 2, comma 4. Yeah. Okay. Don't forget the union. All right. Last one. Find the values of x from which f of x is greater than g of x. Where is f of x greater than g of x? Anybody besides you? Where is it above? -2 to 2, right? Okay. So E is -2 to 2, bracket or parentheses. Ooh, I heard both answers. So is it bracket or parentheses? Now we want f of x is greater than g of x. Yeah, we're doing E. Okay. So it'll be parentheses. Yeah, because it's just greater than, right? It's not greater than or equal to. And at 2 and -2, they're equal to. Okay. All right. Now that we went over 7 and 9, we know domain range. We know net change, right? I want to cover 3 to 6. Okay. And it's coming from a graph. Okay. It's coming from a graph. So let's do it. Okay. Okay, so increasing, decreasing, local min and local max. Okay. First off, let's talk about increasing and decreasing. So it says 31 through 34, the graph of function f is given. Use the graph to estimate the following: the domain and range. We're gonna skip the domain and range, okay? Because I'm not gonna focus on that. You guys already know what to do with that. The intervals on which f is increasing and on which f is decreasing, okay? So we're talking about increasing and decreasing. And if you look at your notes, it says intervals of x values. So your answers are going to be x values, okay? Where the graph is going up. So if you think of a graph, right? And you think of a roller coaster, let me just draw a roller coaster for you. Yeah, and you just fly out. Okay, so this is the roller coaster, right? Yeah. Okay, anyways, let me. So you start off here at the roller coaster, right? Everybody rides it up here, and you're going up, Increasing says intervals of x value where the graph is going up from left to right. So we read this graph or we read this roller coaster from left to right. Okay, just like how you read a book. And you're going up, 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 right? That's where it's increasing. Okay? And you hit this point, and then you go down, 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 down. So from this point, that's where it's decreasing. And you are also increasing from here to here, right? Because you're going up from left to right. Okay? Now, again, when you're on that roller coaster and you're going from left to right, your body is looking at the sky when you're increasing, and your body is looking down, or your eyes are looking down at the ground when you are decreasing. Okay? But there is a point where you're not looking up or down, right? You're looking straight ahead at the horizon. Yeah? And it's that oh crap moment when you start off here and it goes click, 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 click. Oh crap, it's starting. Oh crap, it's starting. Oh, swear word is starting. Oh no, I want to get off. At that point right there. Yeah? At that point right there, you are straight looking at the sky. Right? You're not looking, you're not looking up, you're not looking down, you're looking straight. Right? This point right there, you're neither increasing nor decreasing. You're level. You're at the top of the mountain. And if you look at your notes, that's the local max. Yeah. Okay. And then after that, I don't like how I use the black on black. And then after that, you decrease, 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 right? And then your body is at the point where it's jerking, right? You're looking down, and then you have that ultimate feeling, that ultimate elevator feeling in your stomach, right? Where your body all of a sudden is going up, right? Yeah. Whenever you have that feeling, there's a split second here as well where you're neither decreasing or increasing. You're going from decreasing, right, to increasing, right? And when I do that, there's a split second, look, I'm decreasing, there's a split second where I'm looking straight. Yeah? And I'm increasing that, and that on a roller coaster goes really quickly, right? And at that point right there, there is the local minimum, or you're at the bottom of the valley. Okay? And then your answers for increasing, decreasing is just going to be from this interval to that interval. Do not include that point. Yeah. And then from this interval to infinity, and do not include that point. Okay. At that point, it's going to be your y value. Your local min is going to be your y value at whatever this x value is. And we'll do an example. This is going to be your y value, local max equals y value at your x value. Okay? Questions on this sort of example here? No? No? We're good with that explanation? Okay. That's what I wanted to do on the board. Let's go back. I'll turn this off. Let's go back to here. Yeah. And let's go back to this. Okay. Again, I'm just focusing on part B, intervals on which f is increasing and intervals on which f is decreasing. I'm going to also add my local max and my local min. Let's do 31. Okay. So here on number 31, it's increasing from left to right. This point here at -1 to 1. Okay. It's also increasing at from 2 to 1 to 4. 2 to 4. Right? So union 2, 4. Okay. It's decreasing from 1 to 2, right? Yeah. So remember, notice class that there's a 1 here, there's a 1 here, there's a 2 here, there's a 2 here, right? So I know my local max and my local min is at those points where I did not include them. Okay. So my local max would be this point right here of 1, 2, 3, has a value of 3 at x equals 1. There's that point right there, right? Oh, you guys can't see it. Yeah. There's 3 at x equals 1. Or I can ask you for the coordinate 1, 3. Okay, either way works. And then my local min would be here at -1, -1 at x equals 2, or 2, -1. And these points, and these are not intervals. Yeah, they are points. Okay. Cool. Never brackets for increasing and decreasing, because then those points is your changes. Yeah. Okay. Questions? No? That is the lesson for 2.3.